stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, I am Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to go back to our JS effects library that allows you to develop, or that is going to allow you, when it's done, in the near future, going to allow you to develop better looking, easier to develop JS effects. So real-time audio processors for REAPER. And the first thing that I want to do, the first item on the menu, is to clean up some tests that we wrote when we were exploring the concept of drawing to a different canvas and playing with brightness and contrast, and all that's good stuff, but it is just clutter in the middle of our tests. So let me show you what I mean, and that's just a leftover from our previous streams. So let's bring in the tests. Oh, actually there is a problem. Okay, I was not expecting that, but let's find out what's happening here. So this transition duration, okay, it's not here. Okay, I was migrating this from the design system and I forgot to fix the syntax. Easy enough. Should be good now. It is good now, so you can see that this was supposed to be showing the results of running the tests, and it's not doing that. It's just showing this weird artistic image. So let's clean this up. I think that everything below here doesn't belong. But I will paste this code here because it will become important for documenting how to use brightness and how to draw to different destinations. So I don't want to throw this code out, because this will be good for documentation later. Now it should be just the test results. Yeah, it's just showing that all the tests so far are passing. Great. Now let's implement the main thing that is the main course of our menu today, which is the idea of circular counting and circular buffers and that sort of thing. And we already had an implementation of circular buffers in the old version of the library that we are sort of recreating and migrating. But I want to start with something even more basic than the circular buffer that we had there. And in case you have never heard of a circular buffer, it's just, well, a buffer, so it's a space in memory, a chunk of memory, a bunch of slots, and you are going to visit these slots in turn, and when you get to the last one, you circle back to the first one. That's a data structure that is useful for things like when you are doing a delay and you want to store samples because you want to replay them, or if you want to draw a waveform on the screen, then you want to have a circular buffer where you write the waveform as the samples come in, and you want to visit that circular buffer in the user interface to do the drawing. Very useful data structure in general. But there is something even more basic, which is the notion of circular counting. And that can be useful in some contexts too. Depending on the kind of operation that you're doing, you don't want to run that operation on like every sample. Let me give you an example. Suppose that you are doing a synthesizer and you want to respond to different notes with different pitches, right? Because that's what the different notes of the keyboard are supposed to do. Now, you don't want to read pitches every sample. First, because the person is not able to play different notes 48,000 times a second. Also, it would be very expensive in terms of CPU cycles to recompute the internal state of the synthesizer on every sample. So one thing that you can do is to look for the notes and to reconfigure the synthesizer. So maybe reconfigure the oscillators in the synthesizer, that sort of thing. You can do that in the block. So that's a common solution that you will see in many situations. So instead of having, we don't even have a sample block here in our tests, but usually you do audio processing in the sample block. So you do something like sample 0 times equals 0.5, which is something that is going to reduce the level on the left channel by 6 dB approximately. So usually you do processing of samples as they come in the sample block. And if you want to run something only every so often, you'll see many effects that do this on the block. The block is only going to run once per block. Well, kind of obvious, isn't it? But a block is determined by this configuration over here. So for instance, in my current REAPER configuration, it will only run that block every 1024 samples. And that's okay in many cases, like when you are doing MIDI, you're reading MIDI from a keyboard, then reading the MIDI every block is kind of okay. But depending on what you're doing, like if you're reconfiguring in the internal state of the synthesizer, then doing that on the block is probably okay. But that means that if you change the block size, it's not only the CPU usage that will be different and your latency that will be different, because those are the two main differences when you change the block size. Bigger block size is going to make the CPU do, or it's going to give more time for the CPU to work, which means bigger latency, but a lower load on the CPU. But then if you do stuff like reconfiguring your filters or something in the block, it will have an effect on the samples that come out. And I would venture to say that like 99.9% of the cases, it doesn't matter. You will not be able to hear such a difference. But it feels wrong. I think it is technically wrong to do that kind of operation in the block. Like if you're reconfiguring oscillators in a synthesizer, you want that to be on every like 256 samples regardless of the block size, or something to that effect. So what I'm going to implement now is this notion of circular counting, so that you can do something in the sample block, but it will only occur every 256 samples. And the basic notion here is that we want to have a counter that is going to count up to some number, and then when it wraps back, we will want to run whatever block of code we want to run, like to reconfigure the oscillators in a filter or in a synthesizer. Right, so let's see where we want to implement this. Definitely before the design system, probably after arrays. No, I'll do it before memory allocation. No, I'll do after arrays, because I think I will need some memory for that, but we'll see as we start designing this API on how this is going to work. I'm going to call this the circular counter, and I'm going to define a function that is the circular counter new. And I'm defining a function this way because I think I will need some memory, because the way I think about using this function is like this. So let's maybe go here to our tests and define something in the sample block, or maybe even in the tests. Right, let's start writing the tests for this. So I'll copy the tests for array, and I'm defining this after arrays. So that's just perfect location. And I'll call this circular counter. And then my circular counter will need a count of how many times I want to go around. And I'm thinking about how I want to write this test. I'm not really sure. I definitely don't want this part. This doesn't make sense either. And even the notion of looking into the circular counter this way doesn't really make sense. So I guess I'll just have a something. I don't know exactly what to call this. It will start at 0, and then I will do some work, and I will expect something to be equal to 2. And this something that I'm going to do is circular counter something like this. And I expect the circular counter something at this point to be equal to 1, because I expect this to have run. So call this the circular counter something 1, and I expect that to be 1. Then I will run this. So it's going to go around the block, let's say 3 times. So it's already at number 1, then 2, then 3. And it started at 0. I want to say that my circular counter starts counting at 0. So this I expect to be equal to 1 as well. So the first time I call this, it runs the block. So you can see why I want this to be something that allocates memory. Because I will want to have a function that looks like this, that will increment the circular counter, but also return me true or false, whether I should run this block or not. And the first time I call it, it should run. So if you are configuring oscillators in a synthesizer, you want to configure the oscillators to begin with. And then the next time around, and definitely you would not, in reality, use code like this. You will not be copying and pasting this block of code over and over. Instead, what you would do is have this on some block of code that is going to run multiple times. Right now I'm writing this code in the init block, but you could have it in the sample block. And this is a loop. So this is going to be in a loop, so it will rerun this over and over 48,000 times a second. But now for the tests, I want to copy and paste because I want more control over the execution, because I want to test if it's doing what it's supposed to. So we'll go around the block a couple times. So for 0, I expect the something to be 0. So I guess this something is like my counter or my executions. That's what it is. So it executed at this point, executed at this point, executed at this point, and every time that it actually executes the block, it's going to increment. Right, that's perfect. So expect at this point to have not executed, then at this point, I expect to have executed this time, and then this will be not, this won't be executed. So 2 is going to be 1, and then we want to go around the block 3 times. So it's 0, 1, and 2. So by the time we get to 3, we expect to run this block, to have run this block. So I expect this to have run. And this about concludes the test. Well, something doesn't add up. Because I only I have two number ones here. Expected to have 3 number ones because I want to go around the block 3 times. So there is something off about my mathematics here. It's just one of those, it feels like 80% of what I do on the stream is like trying to figure out off by 1 mistakes. There's something off. To begin with, it's 0. This time it should have executed, so 1. Then it should not have executed and not have executed. Not and not. So this should be 1 as well. And then 4 should be 2. And now I have 3 number ones. Okay, let's see if we implement this, if we can implement this right. We have 2 functions, one to create the circular counter, and this is going to be like the count. And you know what? I don't think I want to call this a circular counter necessarily. Yeah, no, I'll call this a circular counter, but I'll also take a step here. And maybe some initial value and maximum value. I think that will come in handy when we are doing the waveform display. Yeah, so I think I'll use a different technique here. It will be from, to, and step. Yeah, so it's going to go from 0 to 3 in steps of 1. And this step is not inclusive. Yeah, okay. So now we need to allocate some memory for this. And I think I have another case. No, I remember having another case where I left some underscores, but it seems like I revisited the place, so that's fine. So now let's have a circular counter, which is equal to some chunk of memory. And when I allocate memory, I just need to give it a size. So we need to think about what are the places that we want to have in memory. So we'll have a counter. Well, let's have a from, a to, a step, and a counter. Which means that we need 4 slots in memory. And then the circular counter at. So we're going to initialize all these places. And the counter is going to start at from. Do we always want that? Probably yes, but I'll receive it as a parameter as well. So it will be counter, from, to, and step. I guess I will reorder this. Okay, so far so good, and this is what we want to return in the end. And this is the only local variable we need at this point. But we also need another function that is just called circular counter. And in here, we will need to do something like this. To get a hold of all these values. And then we need to increment the counter. So counter plus equals step. And if the counter is greater than or equal to 2, so I'm assuming that I'm always counting up, or that the step is always positive. I wonder if I am making this too general and if it's going to be too slow, because I'm doing 4 memory accesses. I'm doing a bunch of comparisons and everything for something that was supposed to be fast because it's going to run every sample. I don't know. We'll see. Let's continue and then we'll see. We'll see if this is bad. Right. So if my step is positive, and in here, if my, oh no, I also need to do this differently. No, okay, this is fine. Yeah, I always add even a negative number. That's okay. So if my step is positive, I'll check if I am greater than or equal to my 2. And if so, I will say counter minus equal the difference from 2 to from. And I'm making this so generic that I think I will need a bunch more tests to test the negative steps, to test fractional steps and all of that. So maybe this is actually a bad idea. We'll see. And over here, I'll test if I have a negative step, then I just need to change the check, but the calculation is the same. then I need to return whether I need to run this again or not. And I guess that amounts to just counter less than or equal to from, but only if my step is positive, so. No, that's not gonna work. Okay, so another thing that I know I need to do is I need to update my counter. So just take this line because I need to do that because the counter has changed, so I need to update it. And then, okay, let's just consider the positive case for a moment and try to make this test pass. What I need to do essentially is to check if my counter is equal to my from. Let's see if we have the test passing, because now it should be, I think. Needs 4 parameters, and I only passed 3. Oh, I forgot to save this file, that's why. The circular counter is failing. Let's dive in there and figure out why. So that's fine. That's incorrect already? Okay. Oh, because I am doing the addition first. Over here I'm updating the counter first, and then it will have been updated already. Let's try it this time. And now it's passing, great. So now we just have to figure out all the edge cases for this. Like negative counters. Fractional counters. And that sort of thing. I can continue pursuing this. And it's going to be a super generic counter. Let's see if it's worth continuing pursuing this. Let's see what the waveforms are doing, because I think all this generic logic will be necessary here. Extract this notion of circular counting. That's exactly what we are doing. And this whole thing about advancing the circular buffer and everything will be much more natural once we get this circular counter working. Yeah, so I think I do want this very generic and powerful circular counter that is able to count up, count down, and it will not be the fastest thing you can imagine, but hopefully it will be okay. Yeah, I guess with everything else, I'll wait for this to become a problem. This is not the counter, this is the count. Yeah, I'll rename this. This is the count. Let's see if I got all of them. Seems like I did, so the tests should still be passing. I just renamed the variable. And they are. Okay. Let's review what we have. Right. Everything in here seems to make sense. So I'll commit what we have. Next, we need to think about negative counters. Go that step down. So I guess I'll call this circular counter. Oh, I have a name for this, should run. And here I'm calling execution, so I need to decide on execute or run. These are two different words, and I need to pick one. Bo is here. Hello, Bo. It's great to have you. And how is it going? Well, it's going well. It's not too bad. Some relaxing JS effects today. How about yourself? How are you doing? Yeah, I'll call this should or execute. Yeah, good enough. So let's write some tests for negative counting. Let's start by renaming this. Instead of calling it circular counter, I'll call it circular counter dot positive. And when I say positive, I mean the step is going to be positive. So all of these execution variables, I'm going to prefix with positive. I feel like I am getting in kind of very circular thinking here, but I feel like the story of this library is it gets complicated and generic, then I see it's like too slow or too complicated, so I simplify, and then it gets complicated and generic. But at least I'm not doing the same complications and generic thinking again and again. I am trying to extract something that previously I determined was worth extracting. So yeah, I'm not just running in circles, hopefully. Okay, I hope that the same mode is good, Bo. So circular counter, I also have to rename these instances. And I think with that, I got everyone. And if I am right, then this will still be passing. Nope, it's failing. So I must have missed a variable. Oh. I didn't miss a variable, but I swapped the extensions. So that should be passing now. Let's try it. Now it's passing. Great. So we already have a test for the positive ones. Let's change it. Let's more or less copy the whole thing, but I'll be careful. And then this one is going to start at 3, go from 3 to 0 in steps of -1. So and then the result should be the same. The number of executions should be the same. But the logic here needs to be corrected. Or maybe not, because I am being smart and thinking about the from and to reversed. So maybe the same logic will work. Hang on, the count is going to start at 3. So count is going to be 3, and my 2, let me put this below so we can compare and reason about this. So count is 3 and 2, 0. So no, I do need that logic. Yeah. But with that logic in place, there is a chance that this is going to pass already. And it does. Great. So that means we got negative steps in the bag. Good. Now we need to think about fractions. Start by doing the easy part, which is just rename this negative into... do I want to do positive fractions and negative fractions? Probably. So this is going to start at 0, go from 0 up to 3 in steps of 1.7, for instance. Or maybe 1.3, because... Oh, maybe 1.4, because that will be interesting, won't it? I think so. Yeah, let's reason about what should happen in this case. So I start at 0. This one is supposed to run. Then this one is supposed to run. Then I am at 1.4. At this point. And this one is supposed to not run. And I'm at 2.8. Then this one well, what is 1.4 times 3? That's 4.2. So 1.2. Because it goes 1.2 over 3. 1.2. So that one is supposed to run. Which means that number 3 is already supposed to be 2. So this guy is supposed to be 2, because it's supposed to have run already. Then, yeah, let's do some more. What's the next one gonna be like? This guy, I expect it to be 2.6. So it's supposed to not run. Number 2 there. Great. And if I do it again, expect it to be at 1. And then it's supposed to run again. To have run again. And if I got all of this right, then I think if this test is passing, then I think that we are in a good place. That's good enough, I hope. Oh, this is supposed to be 3. Okay, so let's see the implementation for this. Well, first of all, this simple check of the count being equal to from doesn't suffice. We also have to check whether we wrapped around. Let's extract this notion because this code repeats. So let's extract this notion. So have a wraps variable that will start false. Yeah, let's do this in a single pass. If my step is positive and this, or if my step is negative and that. And then in this condition, I don't need to extract a variable for this. But I can overwrite execute to be true. I'm going to try to make this a bit more readable with the parentheses, but it doesn't really change the meaning of anything, because the and is already going to execute first and the or is already going to execute second. So it doesn't change the meaning of anything, but the parentheses makes things a bit easier on the eyes, hopefully. And I guess now this works. So if my count is equal to my from, that's when things are just starting, then I'm going to execute, and then I do the increment, and then I check if I am over, and then wrap the counter around, and when I wrap it, I say that I should be executing. I think that's incorrect. Let's circle back to the first case. And the internal counter is going to wrap here. But I don't expect this to have executed. I'm off by 1. Damn it. But I think that now this circular, I think that the fractional one will work. No, not even that. I think the fractional one may work. Let's comment everything else out. So now the fractional one is working. But the positive one will be failing. And it fails. Let's commit what we have here, because even though it's wrong, it's progress. Just maybe in the wrong direction. Now we have to think about this idea. Do we want the first one to run, or do we want to run when it wraps back? I think we want to run the first time. So for that, we actually need to store, because so it wraps back, and on the next one it should run. Right? I'm offsetting everything by 1, whether I run on the first time or not. So I want to run the first time around, which means that I will have to store whether I should execute next time or not, which is kind of a silly thing, but well, to begin with, I want to execute, so I will put a true there. Then, when I'm getting a hold of all the values, I will also do that with execute. And execute is a local variable, but so are all these other variables, which I forgot to put there. So how about we fix that right now? And maybe all of this too fits in one line. So let's see. Okay, all of that is making sense. So now when I update this, I should not be updating that, I should be updating this. And otherwise, and now the test will pass, I hope. All of them. And they don't. As you would expect, things go wrong the first time. Okay, this is already, oh no, that's okay. That's expected. This is fine. This is okay. Still working. Oh man, I need to figure this out because I hear myself with an echo. It means that it's time to go. People expect me in the other room. Okay, so this is where the issue is. Why is this going wrong? It's this guy. This is still a 1. Yes, it is. And then all of the rest of them are like this. So is the problem my test or my logic? I'll figure this out and I'll wrap it up. Well, if I do this, then the tests are passing, which is good news. Let's work through the logic again to see if I fix the tests or if I still have a problem with my logic over here. Five, that is correct. What's up with this? So it starts at 0, so I expect this to be 0. Or let's reason about the counter. The counter starts at 0. So on every line that looks like this, after the line, I want to reason about what the counter became. So it starts at 0, then 1.4, then 2.8, then 2.8 plus 1.4 minus 3 because it wrapped around 1.2. I think that these numbers are correct. They are the same numbers as what we had before. So it wrapped around. It should be 1 at this point. So I expect the thing to run here. So this should be a 1. And it is. Then I don't want to run here. I don't want to run here. I do want to run on this one. So 3 should be 2. And it's not. Yikes. Well, see you later, Bo. I'm having a very hard time wrapping my head around all this circular situation going here. So this is going to wrap around. So on this call, it is going to wrap around, which means that it's going to set up the next one to run. Well, I think I fixed the tests. Yeah, I think that this is correct. Because let's think about how long it takes for the other ones to wrap around. It goes from 0, 1, and 2, and then it wraps around. So it executes 3 times. And here it's 0, 1.4, and 2.8. Yeah, let's try, instead of 1.4, let's try 1.7. I think that's what's going to give me the result that I'm expecting. So it's going to be 1.7, then it's going to be what's 1.7 plus 1.7? It's 3.4, so it wraps around and goes to 0.4. So this time it took 2 cycles to wrap around, or 2 numbers to wrap around. So it's 0, 1.7, then it's going to set up the next one to run. Yeah, okay, this is more like what I wanted. So this is going to become a 2, and this is going to become a 3, I think. Yeah, but let's do this by hand. It's now 1.7, so 2.1. And then 0.8. 2.5. So it starts at 0, which means that this guy, well, this guy is supposed to run. So this 1 is supposed to be 1. Then it is going to wrap around, which means that 3 is supposed to be 2. Great. And then it's going to wrap around, which means that 5 is supposed to be 3. Okay. I think I got it this time, but we'll have to check. Great. We got it. Amazing. Very happy. So the logic was right, the test was wrong. Now the circular counter is doing what I think a circular counter is supposed to do. And it takes in account positive values, negative values, and even fractions. And I think that negative fractions will work just the same, but let's implement them real quick because it's so easy. So you gotta copy this, move from positive to negative, and then we'll go from 3, we'd start at 3, go from 3 to 0 in steps of minus 0.7. Copy these lines and change positive to negative. And it's still passing. Great. So with that, we are going to conclude. So we implemented the notion of circular counting, which is just this thing that allows you to run a certain block of code certain number of times, and that is independent of your block size, and that is, it handles positive values, or positive steps, negative steps, and fractions. So pretty much does everything you could want to do. So I think we succeeded in this. We extracted the notion of circular counting. Great. Tomorrow, we're probably going to try to do the circular buffer, which is an idea similar to this. Yeah, but it's going to have the data structure and it's going to circle around. And I'm not sure I will use the circular counter for this. It's just maybe this circular counter will stand alone. But yeah, I think that the circular buffer will use some of the same logic, but I don't think it makes sense to use the circular counter because on the circular buffer, for instance, the step is always 1. So this whole work of dealing with negative numbers, the work of storing the step and everything, all of that is extra. So we will probably optimize things by implementing everything by hand. So That's what's up tomorrow. Thanks for being here, and I see you tomorrow at the same time.